Good afternoon, all. Before we dive into the session, I am delighted to introduce the profile of our esteemed guest. Dr. C. Chandramouli is a distinguished entrepreneurship ecosystem leader and academic professional who currently serves as the CEO at Atal Incubation Center, Sri Krishnadevara University. With a robust academic background, he holds a PhD in embedded systems, robotics, and virtual instrumentation, which he completed between 2010 and 2015 at Sri Krishnadevara University. Dr. Mowli is widely recognized for his significant contributions to innovation and entrepreneurship, serving as a mentor at prestigious organizations including Atal Innovation Mission, Niti Aayog, and Startup India, and extending his expertise internationally as a mentor for Innovate Bhutan. As an innovation ambassador designated by the Ministry of Education's Innovation Cell, he is dedicated to championing innovations, supporting startups, and fostering entrepreneurial ecosystems, and demonstrating a committed approach to nurturing emerging technological and business talents. With this introduction, I warmly invite Dr. Chandramouli to join us on the virtual platform and take the session forward. Thank you. Over to Chandramouli, sir, please.
So thank you very much for the nice introduction. So I want this session to be more interactive than, coming here and presenting some PPT and giving some GAN and going back. So I don't want such kind of session today. Okay. So I have good experience in, handling online sessions. So that's why I keep on, tinkering with a lot of online tools where I can interact with participants during these sessions. Okay, so I'm also going to introduce one tool. Maybe few of you might have went through those tools, so where you can interact with me and you can answer in that particular tool from your laptop or mobile phone, wherever it is possible. Okay, so thank you, sir, for introduction and inviting me and giving a good opportunity to interact with the faculty members, eminent faculty, I should say, and we have good number like 60 faculty who are coming here and spending their time to get some knowledge on the new generation or next generation, what kind of semiconductor devices that we need to work on, how we can bring sustainability in different stages. This is what our topic is today. As Chandrababu Garu told, I am from Atal Incubation Center, which is supported by Niti Aayog, Government of India. Under that, there is a think tank called Atal Innovation Mission. Okay, and this think tank always thinks how India can be prospective global leader in future. Okay, so that's where this Atal Incubation Centers, Atal Community Innovation Centers, Atal Tinkering Labs, and there are a couple of good programs, vernacular language programs, Arise programs were evolved. Okay, so in that one part is Atal Incubation Center, and we are the first set of Atal Incubation Centers recognized by Niti Aayog and funded by them as well. And of course, state government and Startup India, Invest India, and couple of NGOs and corporates like Arja Steels, HDFC Bank, they are also supporting us in nurturing innovations and startups, especially sustainable innovations and sustainable startups. Okay, so if we say sustainable, that means we always tell to our innovators and startups that they have to keep in mind when they are innovating or when they are developing business models, they have to make sure that their businesses and innovations must be sustainable, and also these should be aligned with any one of the UN Sustainable Development Goals. There are 17 such UN SDGs available. So they have to link to that particular Sustainable Development Goals. So otherwise, whatever you are innovating without such values or sustainability, so then it's a waste of innovation. That's what I believe in. Okay. And I think this is the right session for me, keeping my experience and my PhD and also what I am doing currently, sustainable startup ecosystem development. So I think this is the right platform for me and the right topic to deliver the session. Okay, so let me give you what we do in Atal Incubation Center, who we are and what is our vision. Okay, our vision is to reverse the talent migration, especially in rural areas and small towns. And we want to retain the rural youth. Okay, so through entrepreneurship, innovation, technology enablement, so that they don't want to go to the Bangalore or Hyderabad metro cities for job seeking and everything. Okay, we want to create the innovations, we want to solve the problems in the local itself, creation of enterprises, businesses, and also job creation, wealth creation, especially in the small towns and rural areas. That's what our intention is all about. Okay, so we work pan India. We have startups all over India, and we operate from Anantapur, Andhra Pradesh. Most of the faculty might not be knowing where this Anantapur is. Okay, so you can visit. Anantapur is a wonderful place. You can see a lot of world-class innovations in our incubation center. Okay, so coming to see, we are incubation center and we support startups in various fields. Okay, to be precise, we support startups in 4 sectors, that is agri and food processing, because in this region, most of the innovators and the startups or individuals, they are directly or indirectly, they're depending on agriculture and food. That's why we kept that agri and food processing as one sector to support the innovations and startups. And then circular economy is one big thing we are doing, where we are, we want to convert the waste into value, the wealth. Okay, we don't want waste to go as waste. We want the waste to be some kind of value addition. We have to bring some value addition to the waste and convert it into a product or service or whatever it is. Okay, so that is one of the primary focus of our incubation center, and we support startups in that region also. And renewable energy, of course, the manufacturing and tech enablement. And these are the services and value differentiators we provide to our innovators and startups. I think with this small slide, I think you might be knowing what Atal Incubation Center, Sri Krishna Deva Raya University is, and what we do here in AIC SKU. In short, we call it as AIC SKU. Okay, if you understood this thing, can you put in the chat box SYES? Or if you have any questions, you can put a question there. I want everyone to participate in this. Okay, so I'm getting some answers in the chat box. So only 2 participants responded. Okay, all right. I'll give you 10 seconds of time to respond. Okay, so I got good answers, fine. Okay, so now let me move to the next slide. Okay, so this is what I told you about, I want to bring a lot of online interactive tools, okay, for you. So I have a small poll for you, and stop sharing the screen. I will share another screen. Okay, in the screen you can see on the top, okay, go and visit menti.com and enter that quiz code there, that quiz code. Okay, so now enter your answers here. Who are you? So whether you are a faculty member or a research scholar or student, or you are a startup founder or innovator, or if you are a farmer, you can put it in the farmer or any other household woman, or any other profession you are in. So you can put it in others. Okay, I got one. So we have one faculty. Very good. See, you can see the results here. How many number of students are there, faculties are there? You can see here. Okay, fine. So let me keep it open. Okay, let me keep it open. And I have one more answer here. One more question for you. I'm scrolling it to next slide. Okay, so we have more faculty with this proposition. I can say that we have more faculty. We have students and research scholars also. Fine. This is for my idea. So now, can you see the next? Okay. So why do you want to attend this particular session? So what is your intention in attending this particular session? You can type your responses. Why you want to attend this particular session? You want to get the knowledge of what is this sustainable semiconductors and what is the manufacturing procedures for these sustainable semiconductors, or you would like to know the value chain of how this can be reused or recycled. Very good. We got one response. Gaining knowledge. Very good. Whatever you write, it will reflect here. I'm giving you the time. Okay, so want to know about semiconductors. SC means semiconductors. Okay, fine. Good. Hope you can see the screen of why you want to attend this session. That's it. Okay, fine. So you want to gain the knowledge. Okay, want to learn AI in semiconductors. Okay, AI in semiconductors. This is something new. Okay, so I'm also covering that point as well. Okay, I will give you the intentions of what we are learning in this particular session. Semiconductor technology. All right. Okay. Fine. Good. Good that you are habituating to this particular tool. That's it. Okay, so to get exposure to recent, what is this recent? Okay, recent semiconductor technologies. All right. All right. So let me take one more question from you. Okay. What comes to your mind when you hear semiconductor recycling? What comes to your mind when you hear semiconductor recycling, reusing of semiconductor or sustainable semiconductors? What comes to your mind when you hear about semiconductor recycling, especially recycling, reusing, or sustainable semiconductors? Do you think that it is mandate that semiconductor recycling can lower the effect on environment or any social impact, or is it necessary to bring some kind of green technologies into this, or is it necessary that we need to work on the materials which can help us in improving the reuse of semiconductors? So what comes to your mind when you hear about semiconductor recycling? The effect or impact or usage, whatever it is. We got one response. Reduce pollution. Excellent. Excellent, sir. Or madam, whoever you have given. So reducing pollution. Resource management. Excellent. Resource management is also one of the wonderful, mindset. Okay. Okay. Resource management. How we can manage the existing resources or recyclable resources. Very good. Then reusability. We got something in chat box. Reusability. Avanija garu. Okay. Reusability. So can we use it directly? Okay. So then green environment. Excellent. Waste management. Okay. Good. Good. I see 5 responses. Okay. Fine then. Okay. So let us stop this here. Okay. Because we don't have much time to interact. Okay. So then let me stop this here. Let me stop this here. Okay. I'm stopping this screen here. I'm going back to my regular PPT presentation. Okay. So now, guys, let us dive into what let us dive into what we are going to do in this particular session. Okay, the intentions of the session. Okay, first we will understand what are the sustainable semiconductors, and then I will give you the clear picture of post production of semiconductors and also the recycling and reusing value chain of the semiconductors. Okay, this is one of the important value chain that everyone should understand if we think of sustainable semiconductors. Then I will be giving you what are the key challenges in semiconductor technology if we want to manufacture the sustainable semiconductors. So then I will also give you some strategies that few of the companies and startups and their best practices towards a sustainable semiconductor manufacturing, reusing, recycling also. Okay. And also at the final stage, I'm going to give the impact studies of sustainable semiconductors. What will be the impact if we start manufacturing, semiconductors using a lot of care at every stage. Okay. So can someone tell me what are the different stages of semiconductors and how one can make sure that we are having we are going to manufacture the sustainable semiconductors. We will be using this, sustainable semiconductors and also in the packaging, logistics. Okay, all this stuff. Okay, so now let me give you what are the sustainable semiconductors actually. Okay, so before that, let me give you. So what is this, post-production value chain of semiconductors? If you see, after manufacturing the semiconductors, what happens, usually the electronics, most of the semiconductors will be used in electronic devices. So the best electronic devices are your mobile phones, okay, your computers, laptops, and where your camera and also the microphone you are using there, the speakers. Okay, nowadays even fans are coming with some electronic devices inbuilt in that because all are IoT nowadays. Okay, your electronic locks. Okay, so electronic devices, all the electronic devices. Now, if you see the post-production value chain of most of the electronics, okay, first it will manufacture, then it will come to the retailers, then consumers or the users, end users. After that, it may go to the secondary users. Okay, so through some platforms like OLX, Quicker kind of thing, or it will go to the waste management. Okay, so the green color wala. Okay, in that waste collectors, to this waste management, what happens is in between it may be refurbished and it can resell again. Okay, and also there is another step called recycling. So where this can be collected and it can be uh, go through a process. I will give you those processes also. Okay, the right side image which you are seeing here, it is the process of recycling the semiconductor waste or e-waste, we usually call it as. Okay, so first we will collect it, then we will transport it to the recycling plant. And there is a huge process in that in the recycling plant. I will give you that picture also. And we will segregate it and recover the metals and we will send it to repairing or refurbishing. Then after recycling, as per the government norms, okay, so it will go to the commodity market or it will go to the manufacturing market, manufacturing of electronics market, or some goods can be directly go to the consumer again. Okay. So then this is the recycling and reusing value chain of semiconductors. Okay. This is the proper step-by-step procedure that most of the companies like Samsung, Dell, Apple are using this, are trying to habituate this. Okay. Because when we say about recycling and reusing of the semiconductors or the electronic systems, so especially the phones nowadays, if you want to buy any phone, then you can exchange it in the Amazon or Flipkart in whichever platform you are trying to purchase. Okay, and this is what the e-collection waste centers and the segregation stage. Okay, so first we will collect this e-waste. Then the second stage is dismantling and component extraction. On in PCB will be there and dismantling every part and extraction of the components, individual components, and then material recovery. We will do the material recovery, ICs, sensors, okay, and sometimes the lead also we will extract. Okay, so then semiconductor recycling will come into the picture. Okay, so that's where all the semiconductor devices will be segregated and put it aside, and then component testing and certification will happen whether it is working properly or not. If it is working properly, then they are certifying it. After that, if components are reusable, okay, so then component reuse and repurposing of that component will happen. After that, if these semiconductors are really usable, then it will go to the secondary markets and through the distribution channel, it will go. If there is seriously waste in this, then it will go to the waste management and it will dispose to the next stage. So this is the value chain of recycling and reusing of electronic components, majorly the semiconductors. Okay, so let me go through the each stage. Okay, so e-waste collection, e-waste collection. So first, how you collect the waste, e-waste, is the major challenge. Okay, so usually there are different processes. See, the first stage is e-waste collection and segregation. In this, the key process is to get the e-waste from different sources. Okay, the different sources you can see there are electronics from households, from industries. You can collect a lot of waste, used the semiconductors, and also you can tap one more source is production overstocking is one more thing. Okay, and there are different collection models for these things. Okay, the collection models are there are public e-waste drop off points. Okay, so in India it is very less, but still we will be implementing that. So then we have Apple has started these recycling initiatives, and we are calling it as corporate take back programs. Okay, corporate take back programs, and most of the mobile phones, laptops are doing this now. And also, the other model is partnerships with retailers for trading programs. This is another model, okay, collection model. So the second stage is, the segregation stage. Okay, in this the e-waste collection and segregation. The segregation stage is initially the sorting of devices based on the materials and the components. That's it. That is the basic segregation we will be doing at this stage. Then when it comes to the challenges at these stages, so the biggest challenge at this stage is there is lack of awareness and infrastructure for proper e-waste disposal, especially in India. Okay, that's what the biggest challenge lies when it comes to the e-waste collection and segregation. And there is a very inefficient collection in in remote areas like rural areas, small towns. It's very tough, doing such activities in rural areas because the awareness there is very less. Okay, if you take the case studies of particular companies who are doing this e-waste collection and segregation, Dell's circular economy program is there. Okay, so which is recovering used electronics for their recycling centers. They're sending all the electronics to the recycling centers. And there is another certification called e-stewards certification, and which ensures responsible collection and processing of e-waste globally. Okay, so this is another case study I have to mention here at this stage. Okay, so this is about the processes and case studies of that particular stage. Okay, the second stage is dismantling and component extraction. Okay, dismantling and component extraction. The key processes in dismantling is, the manual dismantling is one process where skilled workers will be disassembling the devices to extract valuable components. Sometimes we have gold also in that particular thing. Then most of the companies are using automated systems like robotics assisted with dismantling for higher efficiency and also low power consumption, low cost. All those things will be done in automated systems. And then the next process in this dismantling and component extraction is separation of chips, PCBs, batteries, lead, and also other valuable parts, on the PCB and this electronic components. The technologies we use in this dismantling and component extraction is we have AI powered sorting systems. Okay, so where These AI powered sorting systems can identify the reusable components. Okay, so with image processing kind of technology. Okay, so then we are also using some precision robotics, especially the Apple's. There is a robo called Daisy Robo, which streamlines component removal. It will do all the aspects. Okay, then coming to the challenges in this particular thing, we have you know we have to balance it manually and also automated dismantling for cost and efficiency. Cost is the biggest challenge. So in the morning, what I did is in one of the groups, in FDP groups, I kept one thought sharing question there. Uh, I think one of the resource person called Revanuru Harigaru, he answered that, he shared his thought. Recycling and reusable of the total, semiconductors is a good idea. Definitely, it's a good idea. But the challenge, what he shared is the cost of recycling and reusing. The manufacturing and remanufacturing is the cost is very high. So that way, how we can convert those challenges into opportunities, maybe for your research or for innovation or for any startup company, you can do that. Okay. So then coming to the case studies, few companies are doing this particular thing. So Umicore's automated sorting system is doing this activity, and also the Appy Desi Robo, I told you this. Okay. So then the next stage is, material recovery. Okay. So in this, we have, the key process in this thing is material separation, chemical recovery. Chemical recovery is one important aspect. And also there are another innovative and emerging methods which started like bio-leaching, microbial techniques, and also there are low impact chemical methods. So most of the companies are using now. Coming to the technologies, there are good technology to extract gold, palladium, and also other metals like lead, aluminum kind of thing, using some chemical baths. And I think this is called hydrometallurgy. I think most of the chemistry professors might know this. Then the other thing is, we have another technology where we will be applying high temperatures to the PCBs and everything to recover the valuable materials. And this is called pyrometallurgy. Okay, so because we are applying high temperature, that's why we are using taking this name called pyrometallurgy. And then some advanced solvents we are using. Okay, so one of the company called Jiva Materials is using, to extract, recover the material. Okay. So then what is this? I'm unable to. The next thing is semiconductor recycling. That is the next stage, the fourth stage. Okay. So where we will be, refurbishment of the wafers and also recoveries of the chips. And also we're also, trying to extract the silicon from the damaged chips. Okay. For repurposing into new wafers, or we can also send it to the new other industries. Like we can also send it to the renewable industries like solar panels, where they can reuse it. Okay, so this is one good example. So you can plan this semiconductor recycling. And then we have component testing and certification. The key process in component testing, because after extraction, you'll have all the components. So then now we have to test those components and certify which is working and which is not working. Okay, here the key process is the functional testing is the key processing, and the certification is another thing. In functional testing, we will ensure that the reused chips and components meet performance standards, yes or no. So that's what the functional testing is all about. And also at every stage, whether this particular chips is, at every stage, whether it is working. So they will give the input, power and everything, they will test and they will check the standards. And then the next stage is certification stage. Components are certified for safety and compliance with regulatory standards, because if you are not certifying it or testing it properly, if you are using it directly, then it may blast. Okay. So this is one of the biggest challenges, even with new phones also. Okay. And coming to the technologies, we have ATE technology, which is called automated testing equipment, for high speed, high precision testing of semiconductor performances. We usually use this in laboratories. Even most of the colleges and research centers have this testing equipment. And then we have artificial intelligence based diagnostics. Okay. So where we can predict component lifespan, reliability, working, all this stuff. Okay. So, but the problem here is, as I already told you, the main problem is high cost for this sophisticated testing equipment. And researchers like you has to make sure that how you can bring down that cost. Okay. So then coming to the next stage, it is component reuse and repurposing. Two things we can do here. One is direct reuse, and the second thing is repurposing of the recovered components. Like you can put it in educational kits, research, or low-end devices. For maybe, so you may not need that much high performance. You can use in that places. Okay. And also in reuse purpose, most of the companies, I have seen a company in Hyderabad called Saroka Soft Solutions. Okay, so they are more into developing this defense projects and products, and they have huge, electronic component store where it is not, up to the defense standards. So they want to dispose it. So that's why what we did is we bring that to Skill Development Center, Sri Krishna Deva Raya University. It's a whole sum of full room components. Okay, so we requested that company. That company has given us for reusing for research purpose and educational purpose. And most of the components we are using till now. Okay, that is one of the good repurposing things. When even you also get in touch with some companies, they will be having a lot of equipment components which are not used by them. You can request them to put it in your educational facility. Okay. So then the next thing is seventh step is secondary markets and distribution. That's what reselling of the recycled and refurbished components. Okay, it can be given to various industries, and also material redistribution you can do, like metals and silicon, where you can put it in the new semiconductor manufacturing supply chain. Okay, so taking that, and if it is good, then you can put it to the place where this new semiconductors manufacturing will be happening. Okay, so what are the technologies we use to identify the right markets and the distribution channels? I think the blockchain is one thing we can work on. Okay, so because we need to ensure which recycled or refurbished product or semiconductor is going to which segment of this new semiconductor manufacturing. For that, we need the blockchain technology for traceability. So then we have the last stage. Okay, the last stage is waste management and disposal. Okay, and here what we are doing is we will be processing for residual. Okay, so where if there are non-recoverable materials, and we have to neutralize all these things to minimize the harm. Okay, we cannot totally remove. What we can do is we can neutralize this, removing the hard and harsh chemicals from that materials. Okay, and then the safe disposal of the semiconductor devices after this residual processes. Okay, so and here what we are doing is we need technologies like waste neutralization, where chemical treatments to make toxic byproducts safe, very safe. Okay, so this should be done. That is mandate. And yeah, so who are the key stakeholders in this total recycling and reusing value chain? Okay, so the first one is e-waste collectors. Okay, so there are companies who are doing this, and also so you can also do this through some kind of app where aggregators who gather discarded electronics, all this stuff. So then you can give it to the next stages, okay, of to the recycling companies. I will also give you some case studies of which companies are doing, some good job in recycling. There is a company called Redwood Materials, and Umicore is another big company which is recycling the semiconductors. Okay, so in semiconductor manufacturing, we have to collaborate with recyclers and for material recovery and reuse, and policymakers like government, NGOs, and there are good organizations, institutions like educational institutions should come up with some, regulatory frameworks. Okay, so where, what kind of, the policies we have to bring when we are reusing and repurposing the semiconductors, especially. Okay, and also we should bring up some policies where we can democratize the technology of recycling and refurbishing the semiconductors. This is one more important thing that everyone should note it down. Okay, because if you are planning for any research, or if you are planning for innovation, or starting a company, this is one of the core area you can start immediately. Okay, and e-waste and also the electric vehicle waste is also going to happen, in a bigger way for the next 10 to 25 years. Then technology providers, of course, so one of the key stakeholders for this value chain. Okay, so where innovation should happen at every stage, all the 8 stages. If this innovation happens at every stages, one thing is we can improve the efficiency. The second thing is we have to reduce the cost. The third important thing is we have to make sure that this technology is accessible to even to the small companies. Okay, so fine. So this is about the recycling and reuse of semiconductor value chain. Okay, so now it's again the Menti time. Okay, so one more, quiz. Are you ready to take this quiz? Okay, see, this is not the quiz. In fact, this is about sharing. This is about sharing your thoughts. Okay, if you are ready. Okay, so I got an answer. Yes, Sandhya Ranigar, thank you very much for your answer. I'm stopping this, and now I'm sharing the Menti meter again. Now you have gone through some recycling semiconductor concepts. Okay. So now how familiar you are with these concepts now? Not at all familiar. Very good. Okay. Fine. Very familiar. Very good. Somewhat familiar. Very good. Not at all familiar. Very good. No problem. Okay. Good. We got 6 answers. I think you're playing with this Menti.com. Menti.com is one of the wonderful platform for interactive sessions. You can bring a lot of interaction among the participants. Very good. Yeah, most of the faculty, I think they're not online. Okay. All right. Okay. Somewhat familiar. We got more answers. Shivashankar. All right. We got good answers. Okay. So 12 answers we got. Chandrababu garu, I will be sharing all these answers. In the final, I'm also putting one quiz. Okay. So for that quiz, I'm also sharing all the details with you.
Okay, sir.
You will get who participated, who has not participated, everything in that. Okay.
Sure, sir. Sure,
right, sir. So I'm shifting to the next question. Okay. Be ready with your Menti, this thing. Now, what do you think is the biggest benefit of recycling semiconductors? Reducing the e-waste, or conserving the resources, natural resources, or reducing the carbon footprint? That's one of the important thing. Okay. Or lowering manufacturing costs. What do you think is the biggest benefit of recycling semiconductors? Okay, conserving resources, yes, because most of the chemicals we are using in new semiconductor manufacturing. Okay, good. Reducing e-waste. Okay, conserving resources. I want more thoughts here, because you are attending this program and you want to be the new change makers. Okay, and you will be teaching all of these things to your, students colleagues, principals sometimes. Okay. So now what is your thought process on recycling semiconductors? What will be the biggest benefit here? Lowering the manufacturing costs. Okay, fine, good. So we have one, reducing carbon footprint. Two, conserving resources. Seven, reducing e-waste. Okay. So one more question, one more poll we will take, and we will go back to the session again. In the session, this time I'm bringing a lot of case studies, and I'm also giving you a lot of challenges for innovation and problem solving. Yeah. On a scale of 1 to 5, how important is semiconductor recycling for environmental sustainability? Conserving the resources, reducing the carbon footprint, lowering the manufacturing cost, all these things. How is it mandated that everything should happen? Okay, so you should tell this. Okay, so we got one answer for 5.0. 5, yes, it is mandate on the scale of 5. Okay, two responses. You can see the colorful graphs when you answer. Very good, very good. Good, good. Okay, most of you. Okay, okay. Sir, you can take the screenshot of this one. Okay, good. Good answers. Okay. So most of you agree, strongly agree that semiconductor recycling is mandate. Most of you. Okay. So someone they are not agreeing it strongly. Okay. Okay. All right. Fine. Okay. Okay. Still, I'm getting more votes. I think more participants have started habituating for this. Very good. Very good. All right. I will stop here this particular poll. Okay. Right. So now let me get back to the PowerPoint presentation. So now let me take you to the key challenges. Okay. So this is our next topic. The key challenges in semiconductor sustainability. Why I kept this challenges thing, because most of you might be research scholars or students who are very much interested in identify the key challenges in semiconductor manufacturing and also sustainability, and this will become your future I should say the research topics, right? So one important key challenge is high energy consumption. Okay, to manufacture the semiconductors we need more electricity, and also we need ultra purified water, where we will be wasting a lot of water to get this ultra purified water. Okay, that is the second step actually. Okay, and also usage of some hazardous chemicals in this particular process. Okay, and e-waste, supply chain vulnerabilities. So all these are the key challenges. Sorry. Let me walk you through each and every step. Okay. So when it comes to the key challenges, so one is the high energy consumption in semiconductor manufacturing. Okay, so it is a very is energy intensive process. When it comes to the manufacturing. Okay, so with processes such as wafer fabrication, which requires significant electricity. So when we are using electricity, that means we have to extract it from non-renewable resources. Okay, so that's where the reliance on the non-renewable energy sources in some regions exacerbates the carbon emissions, more carbon emissions, like thermal power or something like that. Okay, so that's why the best remedy for this is the best strategies for this I will tell you in the strategies part. Okay, the second point is water usage, because when it comes to manufacturing of semiconductors we need ultra pure water. Okay, so you might be knowing how much water we are wasting for just mineral water, drinking mineral water. Okay, so almost 60 to 80% of the water we are wasting. Okay, so now this UPW, ultra purified water, is crucial in cleaning wafers, which lead to high water consumption. That is one thing, because cleaning itself is it takes more water. So then the second important thing is managing water scarcity in production hubs poses a significant challenge. This is one of the significant challenges that everyone has to look into. Okay. The next thing is the hazardous materials. In fabrication of semiconductors, we use a lot of hazardous chemicals like sulfuric acid, hydrofluoric acid, and there are others. So we use in etching process and also cleaning process, and all these things are very 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 hazardous for human health and also to the ecosystems, environment, ecosystem, all this stuff. Okay, so that's where again we have to see how we can reduce the usage of these chemicals. Okay, so then the other thing is e-waste. In this e-waste, the rapid technologies advancements which leads to the frequent product, okay, contributing to the growing electronic waste. Okay, so e-waste is one of the biggest problem in the world nowadays. Okay, so how we are reducing that e-waste is again the biggest challenges, because here what we are doing is we are also recovering the rare earth elements and reducing the waste is the critical concern, right? So the next thing is supply chain vulnerabilities, because the total supply chain is the biggest challenge. Okay, so mining of raw materials like silicon, cobalt, or any other earth materials. Okay, and the sustainable and unethical practices of logistics. Okay, and also where sometimes we should also think on the labor rights. Okay, so whether we are violating the labor rights or not, all this stuff. So these are the 5 challenges when it comes to the manufacturing sustainable semiconductors. And now let me go through one more Menti time. In your opinion, in the participants' opinion, what is the biggest challenge in implementing semiconductor recycling on a larger scale? Okay, if you want to do this on a larger scale, what will be the biggest challenge? You can type it. Type your answers and you can post here. Do you think the infrastructure is the biggest problem, or human resource, or the latest technologies, AI-based technologies is the biggest challenge? Or what do you think? Or democratization of the technologies, or lack of support from the government agencies? Do you feel that it is the biggest challenge? I got an answer called good. Okay. Okay, which is the biggest challenge? So, sir, you have to give the biggest challenge in implementing semiconductor research. Lack of awareness is, yes, I totally agree with you. Lack of awareness. Okay. Then I know most of the faculty will give very generic answers, but I'm very, very much interested in definitive answers, definitive thoughts. Okay, what is this? Infrastructure and lack of awareness is the biggest challenge. Correct. Infrastructure, correct. Okay. Okay, that's it. Only 3 challenges you see. What I feel is, okay, government policies. Yeah, so that is one biggest challenge. I think government has to seriously look into these things. Infrastructure availability and cost. Okay, fine. So what about the environmental concerns? Lack of knowledge. Okay, good. So to me, the biggest challenge in implementing semiconductor recycling is on larger scale. Again, see, when it comes to metro cities and developed cities, okay, in India especially, the recycling, all these things are happening. But when it comes to small town and rural areas, it is not happening. That's where I think the lack of awareness to the rural areas, I think that is the biggest challenge. I think the government or the big companies has to take initiatives in collecting, segregating, and also recycling the electronic goods and converting that into the semiconductors and sending it to different portions. Okay, need for specialization equipment and expertise to break down the materials into individual components. Exactly. So we have this AI based technologies now, which is again very but we have to bring it down to the cost effective so that even a rural guy who is having good knowledge on semiconductor manufacturing can work on small with small 10 by 10 space or 20 by 20 space, okay, in their village or in a small town. Technical challenges, yes, agree with you. Good, sir. So next question. How can society contribute to the reuse and recycling of semiconductors? Now you tell me. This is wonderful. I should say the question. This is a very basic question. Like everyone can answer this. If you have electronic components or electronic devices, electronic instruments, equipment in your home, how you make sure that you can reuse and recycle this? See, when I say semiconductors, it's not only semiconductors. We can also take it as electronic gadgets or all these things. One thing is, for me, I will put it in the OLX by having awareness and education. No, so how can society contribute to reuse and recycling of semiconductors? What are the ways? So is there any other way you can suggest? See, OLX is my way where I will put my old phone to sell. Exchange of the devices. That's very good idea, sir. Exchange of devices. Minimization at source. What do you mean by source here? Okay. I mean, yeah. So, I mean, purchasing what we require. That's it. Not extra things. I understood that. Very good. Okay. So now I have my watch. Okay. Now, so recently I got this watch, this one got, damaged. The belt got damaged. Now I had to replace this. Okay. Can this replacing small, electronic components or servicing, high-end servicing skills for the rural youth or small towns, can this be one of the society contribution for this? Foresight during the design and manufacturing phases. Okay, good. Awareness on 3R. What is this 3R? It is triple R. Okay, all right. I'm stopping this here because I want to give you the importance of. Okay, fine. So now coming to this, society contribution. These are some good answers. I think most of you should answer this question by yourself. Okay, so maybe in the feedback thing you can ask Chandrababu sir. Okay, because recycling, repurposing, and reusing of not only semiconductors, lot of electronic gadgets, EV vehicles, and also other waste materials are very important. Okay, so I'm stopping this here now. Challenges of semiconductor industry. See, recycling the semiconductors. Okay, so now the strategies for sustainability in semiconductor industry. Now we will discuss on this. I will not take much time here because I want to give you more case studies on the big companies, how they are doing, and also the recent startups, how they are working on recycling and reusing of semiconductors at every stage. Okay, I'll just go through this simple thing. Okay, so one thing is the first challenge is, the electricity, more usage of electricity during the fabrication wafer thing. So what we have to do, we have to come up with some energy efficient, technologies, and also we have to adapt renewable energy sources for this. The second thing is water usage of ultra purified water. So now here what we have to do is we have to bring up water recycling technologies and also how we can manage in the usage of water, okay, during the process of wafer cleaning and all those things. Then the green chemistry practices, where identifying the chemicals which are low in hazardous, all this stuff. Then design for longevity and circular economy based this thing. Then ethical supply chain practices is very important, where we have to teach the awareness at every stages, including starting from branding, marketing, the logistics, working with the laborers, all places. And R&D investments. I mean, we have to put more money in sustainable technologies here. Okay. Yeah, coming to the sustainable practices by semiconductor companies. I'm just giving you three companies here. One is TSMC, this is Taiwan-based company. Then another company is Intel. Then Samsung, you know better. The Samsung Electronics is another company. TSMC is committed to net zero emissions by 2050. This is their vision. And they are also planning to reduce the water reclamation by 25% by 2030. Okay. And Intel has targeted 100% renewable electricity and net positive water usage by 2030. I think the water usage is the critical issue. So where TSMC and Intel is addressing those things. And Samsung Electronics, they are focusing on energy efficient chip design. Okay, and eco-friendly packaging. I have a video of this one. If time permits, I can share that video now. Otherwise, I will share it to Chandrababu Garu and he will share in your group. Okay. Now, these are the major companies and very notable companies who are following this sustainable practices in semiconductor manufacturing. Now, let me give you startups who are doing at every stage at the value chain. We have this this value chain, right? In that value chain at every stage, which startup is doing their part. Okay. So coming to the first stage is, I think, sorry, what is the first stage? I'm unable to recollect it. Yeah.
Innovations.
No, not the innovation. It is resource efficient. Sustainable practices by startups. The first stage is resource efficient material management. This is okay. So Zyvex Labs is one company which is pioneering in automatically precise manufacturing. They are working on. Okay. So then there is another company who are working on advanced depositioning techniques. Okay. That Mosaic Materials is another company. Okay. So they are working on eco-friendly deposition methods. And there is another company called Amber Semiconductor who are working on low carbon wafer materials, because that wafer manufacturing is the biggest challenge, where most of the silicon, gallium, all these materials will be wasted there. Then, yeah, sorry, the same slide, I think. Okay. The second stage is recycling and circular economy. Okay. So where rare earth element recovery. So Redwood Materials is doing that in recycling e-waste to extract critical materials like cobalt and other rare materials. Then chip recycling technologies. For that, we have Re-Electrify, which is an Australian startup, okay, who are focusing on recovering and reuse of semiconductor components. These are all the case studies and I'm just walking you through. Okay. Then we have energy efficiency in manufacturing. Okay. So there are couple of companies who are taking the innovations. See, the innovations are low power photonics, smart power optimization, and AI driven process optimization. In low power photonics, IR Labs is taking care, and also so they are integrating some silicon photonics in chip interconnects. In smart power optimization, we have Sci-Fi, which is a energy efficient processor designers. Okay, using RISC-V architecture. RISC-V architecture, I think most of the electronic faculty might be doing what is this RISC. Okay, and V architecture. Most of the ARM processors are using that. And AI-driven process optimization, I think Bright Machines leverages AI to optimize semiconductor manufacturing, like the total, to reduce the waste, energy consumption, water wastage. Okay, so all these things they are doing. Then in the next stage, we have Flex Logic, chip flow, and their innovations are biodegradable substrates, carbon neutral packaging solutions, respectively. Then water conservation and management. Dry Itch focuses on developing water-free, waterless cleaning technologies, and Gradient is advanced technology. They are using water recycling systems. And we have one startup who are working in the clean water technology, and they are also on in this, bringing up clean water to the industries. So that company name is Envino Private Limited. And the alternative materials and quantum advances is, Paragraph and QD Laser is two companies they're taking care. Then carbon reduction in manufacturing. We have carbon neutral semiconductor manufacturing, where a company called Carbon Clean Collaborate is doing that. Okay, that means they are also repurposing the CO2 emissions. That's how they are neutralizing it. See, CO2 emissions are mandate for any manufacturing process. Now, after emitting this CO2, how you are neutralizing that? Maybe you can plant these number of trees, you can help the environment to grow, and also you can make sure that the oxygen level of plants and all those things can be grown with your money again. Okay. Then low temperature processes. Pneumat Technologies is doing that. Okay. Then, yeah, this is the final Menti time. I'm taking you. So now rank the stages of the recycling process in terms of their impact on sustainability. Which stage you feel that will give more impact, and also we have to focus if we want the sustainable semiconductors. Is it collection or extraction of the components or materials, or recovering the materials, or you reusing of the components? Which stage? 4 votes we got. And at the top, we have waste collection. Waste collection is the biggest problem. Okay, fine. And this is a good market research activity I'm doing here for all the participants. Okay, component reuse. Okay, fine. I will wait for 2 more answers, then I will skip this. Next, we will go to the next question. So, as per the 97 participants and 8 votes here, the e-waste collection is at the top ranking in the recycling process in terms of impact on sustainability. The second is component reusage. Third one is component extraction, material recovery at the last place. Fine. So now, if you had to prioritize one area for innovation in semiconductor recycling, which would it be? Because this will help you for your research or for your innovations. Is it efficient collection methods? You want to do some research in that? Or you want to do some research in advanced dismantling technologies like using AI, machine learning, collaborating with industries, all those things. Then you want to work on the technologies for improved recovery processes. Then if you want to work on the reuse applications, expanding the reuse applications, this is also one good area you can plan. Where you want to do some research. Okay, good. Okay. Super, very good. Efficient collection methods. Okay. I think you can plan in different ways. Different ways. Okay, very good. Very good. We're getting more answers for this. Very good. Because this is the research topic and most of you might be interested in this. Okay, fine. So now, is that it? Shall I go to the next slide? Okay, fine. So now see, do you think semiconductor recycling should be made a global mandate? Is it a global mandate? Sorry, ignore option 3. Ignore option 3. I have not written it. Yes, no, only I need those two. I know most of you will tell yes. Okay. Yes, yes. Okay, yes. Very good. Okay. So you got be habituated for Mentimeter now. Oh, 10 answers. Yes. Fine. Okay. So most of you think that it should make as global mandate. Okay. So we got good answers. Then what is the one key takeaway from this discussion or session on semiconductor recycling you are taking? This is for my sake. This is my review, actually. So what you are taking from this, don't tell knowledge, skills, all this stuff. Okay, I want some specific answers here. Do you want me to wait or do you want me to skip this? This is the last poll I'm putting. This is for my sake. Using advanced robust technology is one key takeaway. Okay. Good. I think I have bored you much. I think that's why you're not answering this. You can put it in the chat box if you want. Okay, recycling and protecting environment is very must and need of the hour for our own survival on earth. Exactly correct. Nowadays, all are required to work on semiconductor devices and need to improve more. Very good. Recycling helps in sustainability and green technology. Correct. Sustainability of human race again. Okay. So thank you very much. I'm just, yeah, this is the end of the presentation. Not the end of the presentation. This is the end of this Mentimeter. Now let me go back to my presentation. Okay. So just to give you the brief of what we did so far in Anantapur, Andhra Pradesh. Okay. So we have supported more than 50 startups and we have generated more than 250 jobs and we have supported more than hundreds of innovations. We handholded, schools, higher education institutions, even PVKKIT is one of our academic partner and we are planning to take one entrepreneurship development program to the students of their institution now. Then we raised more than 750 lakhs of rupees to support our startups. And also our startups, they have raised more than 250 lakhs of rupees to external funding, that is external funding for their businesses and innovations. Okay, so we have 17 plus awards to our startups, and recently AICSKU got the Rural Best Incubator Award. This slide shows what we are doing for the past 6 years in the region of Anantapur, Andhra Pradesh. I'll just scroll out our products, okay, just for your sake. Okay, these are all the world class products. This is world's first liquid free e-sanitizer. Okay, these are all other products you can see of our startups. Okay, all the products. Okay, I'm just scrolling it down. Okay, so this is the facility of AIC SKU. I request all the participants from different institutions, okay, who participated here. I request you to please come and visit our facility. You can also bring your students, faculty, okay, so that they can see the facility here. They can interact with innovators and startups here. How students can, come up with new ideas and how AICSQ can handhold them. We will brief you here. Okay, so that's all from my side for today. And if you have any idea, okay, and you want to do business with that, please get in touch with us back. Okay, thank you very much and looking forward to work with all of you. I really thank PVKKIT, Chandrababu Garu and the other team members there in PVKKIT for a wonderful, I should say, the platform where I have met, I think, some good faculty members, students, research scholars, innovators, and I think you had a good time with Mentimeter, and also with the session. Okay, thank you very much for that. If you have any questions, put it in the chat box. I'm more than happy to answer that.
Thank you so much, Dr. Moli, for being an integral part of our adult faculty development program on AI integrated next generation semiconductor devices. Your informative talk on sustainability, recycling, and reuse of semiconductors has not only enlightened our participants, but also emphasized the significance of adopting eco-friendly practices in the semiconductor industry. We are grateful for the time and effort you invested in preparing and delivering this valuable session. Your expertise and insights have truly enriched our program. Thank you, Moli garu.
Thank you, sir. Thank you very much. Any questions?
Yeah. So I request all the participants, if you have any queries, please.
If you feel difficult in asking questions here in the chat box, then you can roll out the questions to Chandrababu Garu or in your group. You can share it with me, sir. Okay, I can answer it later point of time also. I know it's very difficult, post lunch to listen that to virtually. Okay, I think I have made a good presentation for you.
Yes, sir.
Yeah. Thank you very much.
You always do, sir.
Good afternoon, madam.
Good afternoon, sir. You always do good presentations.
Thank you, madam. Thank you very much. So kind of you. I have been doing, a lot of research because when it comes to sustainable semiconductors, even I have a video of 10 minutes, where Samsung in 2022, they started this green manufacturing facility, the green semiconductor manufacturing facility, where they have reduced the usage of chemicals and also usage of water as well. Okay, there is a video I will share with you. Please share with the participants. I hope participants got some good enough idea on the recycling, reusage, and the sustainability of semiconductors. Okay, thank you very much, each and everyone. Chandrababu Garu and Deepthi Madam, thank you very much, and other team members.
Thank
Okay,
you, sir.
so looking forward to work with all of you.
Okay, sir. Thank you, sir.
Thank you, sir. See you. Bye.